This is chapter 24, comparing means from independent samples. Independent samples means that one sample does not influence the other. If we look at the test scores for boys and girls, those test scores would not influence each other. If we look at, let's say, the average age of students at Tennessee and the average age of students at Florida, those ages wouldn't influence each other. If we look at the IQ score of people in California versus the IQ score of people in North Carolina, those IQ scores wouldn't influence each other. These are independent samples. So once again, when we look at the assumptions for this, we are going to have identical assumptions with only a tiny bit of difference here, and it's what I just stated. I'm going to scroll down to the assumptions. Here we are. We have the randomization independence condition, which I combine just into one here for condition 1. 10%. Remember, those are staples. Those should be the two things that come out of your mouth. Randomization independence, 10%. Boom. Got 2. You have the nearly normal because we're dealing with the means. Review the last chapter, going a little more in depth on that. And you have independent groups. And that is very, very important, that these groups are independent of each other, that one group does not influence the other. And you'll see this in chapter 25 where it changes with paired means. This is independent means for chapter 24. Now when we go down here, let's go down to what we're actually going to be doing. We're going to be doing a 2-sample t-test. This can be found on your calculator on the stat test button, and 2-sample t-test. You can run your own 2-sample t-test and try some of this by yourself. To get the test statistic right here, if you notice there's a little bit more than we want to deal with on this screen, so I'm going to scroll down a little bit till we get to the one we actually want to see. Just a second here, we will have an actual. Here we go. This is a little bit better. The test statistic T, with degrees of freedom, not described on this slide. We have it somewhere else. The degrees of freedom for this one is the wacky one, and we would have to give it to you, but don't worry about that. The test statistic T is described as the difference between the two means. You can ignore this, that is assumed 0, over the standard error of the two means. So we're going to look at the difference we find from the 2 sample means over the standard error of the 2 sample means, y bar 1 minus y bar 2, the standard error of the difference between the two means. So what we have going on here is a statistical test to try to see if there is a difference, to see if there truly is a difference. We have some tests between stranger and friend right here, where friend was higher. This was selling prices of, I believe, what people would sell to someone on Amazon, or if they would sell at a higher price to a stranger or a friend. For some reason, they sell prices higher to friends. If you notice here, the difference is positive, which means the friend was the bigger number. We have alternatives hypothesis right here with the does not equal, and it looks like that stranger and friend are not equal to each other. You can actually plug in right here does not equal, and that would suffice. We have the alternative hypothesis that the stranger price is higher if you put that greater than sign in right here, and that doesn't have enough evidence. But if we go here to the less than, that the stranger price is less than the friend price, we do have evidence for that alternative. This is done on your calculator under 2-sample t-test. Going back up here, we can also make a confidence interval for the true difference between two means. Scrolling up to the confidence interval, we would actually take the difference from the sample, and then we would choose the test statistic. Remember, the degrees of freedom is a little wacky, and we'd have to give it to you. So usually we just give you this test statistic on test if history is proven, and then we need to times the standard error of the difference of the two means. Once again, this is your margin of error, and this is the center. The center is actually the difference. Let's scroll back down here to our jump output and look at it again. The jump output shows, not this jump output, right here, that we have a confidence interval of negative 26.94 to negative 113.96. This is saying that the true difference between these means is contained in the interval between 26.94 to 113.96. And notice I didn't give enough context. The true difference between the selling price between stranger and friend is this, with someone selling a higher price to their friend. Try doing this problem right here. Try taking the standard error of the differences and solving this yourself.